Hello everyone and welcome to my channel. My name is Dr. Karachi, and in this video here we will start focusing on application-based attacks, and and more focus will be on the common application vulnerabilities and secure coding standard. So the first part of this lecture, we're going to talk about the common application vulnerabilities, uh, based on OWASP top 10 web application vulnerabilities here. If you look at it here, this is the latest one, 2021, and they are expected to release a new one sometime next year. Now, the Open Web Application Security Project is dedicated to finding and fighting the causes of web application vulnerabilities, and they are the authors of the 10 most critical web application papers. Okay, and the site is very useful site if you want to learn about web application security concepts and used by pen testers and software and web developers as well. Now, this is, by the way, the top 10 is a widely recognized, OWASP as industry standard for understanding and addressing web application security risk. In the next slides, we're going to cover each one of them briefly and understand the risk and the mitigation. Now, the first one, we got the A1 broken access control. Rules about the authenticated user privileges are not properly configured. So, now, this vulnerability arises when applications fail to enforce access controls properly, allowing attackers to access or modify unauthorized resources. Examples include like accessing, for example, use other users' data, or modifying permission or escalating privilege. Now, the OWASP recommendation are use OWASP Application Security Verification Standard, ASVS, to ensure proper role-based access control. Now, you should implement deny by default access controls, enforcing strict permissions at every layer. Regularly test access controls through automated tools, like Nessus or others, and do manual penetration testing. And finally, you need to log and monitor failed access attempts to detect any suspicious behavior might happen. Now, in the second part here, we talk about cryptographic failures. Now, this type refers to the incorrect implementation or use of cryptographic algorithms. Common issues can include using like weak or outdated encryption protocols, or like improper key management, or transmitting sensitive data without encryption. Now, OWASP recommend the following. Use modern encryption algorithm. The latest one, we talk about AES 256 and the protocols like TLS 1.3. Also, you need to avoid storing sensitive data unless necessary, and ensure encryption at both at rest and in transmit. Follow the OWASP cheat sheet on cryptography and key management for implementation best practices. And of course, you should regularly audit cryptographic modules for compliance with the standard, such as, NIST standard. Now, injection attacks. Injection vulnerabilities occur when untrusted data is executed as part of a command or query, like SQL injection, operating system commands. Now, this can lead to unauthorized access, data breaches, or system compromise. Now, the OWASP recommendation is to use parameterized queries and avoid dynamic SQL queries as much as possible. You should implement input validation and output encoding to sanitize users' input. And of course, one of the recommendations is to employ ORM, which stands for Object Relational Mappers, to abstract database access securely. And of course, recommended to use OWASP, ZAP, or other dynamic testing tools. Now, for the A4, we got insecure design. This refers to a flaw in the architecture or the design of application due to insufficient security consideration. Examples include like weak workflows, inadequate error handling, or missing threat models. Now, the OWASP recommendation is to incorporate threat modeling at every stage of SDLC, software development lifecycle. And OWASP recommend to follow its own proactive controls for secure design principles and leverage secure frameworks and perform design reviews to identify architectural weakness. Now, for A5, we got the security misconfiguration. Now, it happens from improper configuration of servers, database, APIs, or application setting. Now, this includes leaving default credentials unchanged, exposing unnecessary services, or improper file permission. OWASP recommendation is to disable default accounts, disable unnecessary features, and prevent directory listing. Of course, you need to do regular review configuration against OWASP configuration management cheat sheet and perform penetration tests to detect misconfiguration. For A6, the vulnerable and outdated components here. Now, using outdated or unpatched software components, like libraries, frameworks, or APIs, can expose vulnerabilities. Attackers exploit these to compromise system or data. Regular updates, dependency scan, and using trusted sources for components are essential to address this risk, by the way. So, therefore, OWASP recommends the following: maintain an inventory of all components and their versions using dependency tool like OWASP dependency check. Update all components regularly, prioritizing critical patches. Of course, you have to remove unused dependencies and monitor for vulnerability using tools, like the one you see here on the screen, Depend Bot. Now, A4, identification and authentication failure. Now, these flows involves improper implementation of user identification and authentication mechanism. Like such as weak passwords, missing account lockouts, or exposed session IDs. Now, these failures allow attackers to impersonate users. So therefore, the recommendation by OWASP is to enforce multi-factor authentication, MFA, and strong password policy. Also, you need to secure session tokens using HTTP only, token and secure flags also as well. Now, use libraries like OWASP, Java, JWT to handle token-based authentication securely. Now, A8 software and data integrity failures. This occurs when software updates, like critical data or the CI/CD, which is, or pipelines, by the way, lack integrity verification. Now, all this stuff could lack integrity verification. So, what is the CI/CD? It stands for continuous integration and continuous delivery / deployment. Um, it is a set of practices and automated tools that streamline the process of building, testing, and deploying software. Examples include attackers injecting malicious code into updates or tampering with the configuration files. Now, with that being said, OWASP recommends the following. You need to sign and verify all software updates using signing algorithm. You must enforce integrity checks like hashes for critical data and configuration. Use OWASP Secure DevOps guidelines for secure CI/CD practices here, and implement monitoring and auditing for code changes. Now, for A9's security logging and monitoring failures, now insufficient logging and monitoring can allow attackers to carry out malicious activities without detection. For example, failing to log login attempts or suspicious action may delay incident response. So the recommendation is like this. You need to implement centralized logging and monitoring tools like Splunk or like IBM QRadar for, as a security intelligence. Okay, you need to follow the OWASP logging cheat sheet to ensure comprehensive logging of security relevant events. Enable alerting and incident response mechanism for anomalies like failed login attempts here. Now, for the last one, 810, server-side request forgery, SSRF, these flaws or these vulnerabilities occur when an application fetches remote resources without proper validation, allowing attackers to make unauthorized requests. This can lead to sensitive data leakage or interaction with internal services. Now, to prevent SSRF, you need to validate and sanitize URLs, use allow list, and restrict outbound network access for the server. Of course, it's highly recommended to implement network segmentation to isolate internal systems from each other, especially the critical one, and use web application firewalls, WAF, and tools like OWASP, ZAP to detect SSRF vulnerabilities here. Okay, so we finished the common application vulnerabilities based on OWASP top 10. Now let's talk about secure coding standard. The first one, we have the dangerous comments in the source code. Now, comments in the source code, while helpful for developers, can unintentionally expose sensitive information and create significant security risk if not handled properly. Now, these comments may include sensitive data such as like API keys, database credentials, or server IPAs, addresses, or like references to debug commands, temporary fixes, or backdoors. Now, additionally, these comments can point to known vulnerabilities, incomplete fix, or insecure implementation, making them a potential gold mine for attackers. So imagine if you're looking into source code and you see something like this: bypass authentication for testing purposes. Okay, in PHP. In Python, for example, you might see a message like this: to do, like to do list, fix buffer overflow and dysfunction. So what does it mean? It means that there is a buffer flow issue here. Now, hard-coded credential. This pose significant security risk as they can be extracted through reverse engineering, providing attackers with unauthorized access to sensitive system. Now, temporary credentials or backdoors left in the code during development can become exploitable if not removed before deployment. These credentials are often static and rarely rotated, allowing attackers indefinite access to applications, database, or connected systems. Additionally, leaked source code containing hard-coded credential, like you see here, for example, like admin password, are often stored in the source code, and which basically, and that's what I mean. That's one of the things attackers actively scan, looking for these type of vulnerabilities in application or in a website. Now, let's look at the poor error handling. Now, this refers to the improper management of errors or unexpected scenarios in the software, which can lead to security vulnerabilities. Now, applications are typically written to handle expected scenarios, but when errors occur, improper responses can expose sensitive information or compromise the system security. So, like for instance, displaying detailed error message such as stack traces or database errors. Like I've seen one time, an error happened like when I input several commands into a form in the mobile app, you know, an error happened and it told, it said to me the type of database this particular entity is using, Oracle. So that's Oracle with Oracle version and everything. That's not right. That's not correct. So you are providing attackers with valuable insights into your application architecture, technologies, or vulnerabilities. Now, if you look at this figure over here, so what is the benefit here I have? Now, the error here, okay, is that it's telling me this Apache Tomcat 7.0.68. Okay. Now, from this error, we can notice that this version, okay, you know, it's clear to us the version. So what do we do next? Well, we search online for vulnerabilities, okay, ranging from high to low, applicable to this Tomcat 7.0.68. And we will try to see which one is the easiest one for us to break into it. Now, so the ideal approach to error handling involves managing errors in a seamless and smoky way to the user. You do not release information about your architecture. You want to ensure no unnecessary details are exposed. Logs should capture error details for internal review, not to be released outside. But error messages presented to user must be generic and non-informative here. Okay, so let's look at the race condition. Now, race condition occurs when the timing of the order of events within a system environment is improperly managed, leading to unintended behavior or vulnerabilities. Now, they arise when multiple threads or process attempts to access like shared resources at the same time, but the code does not properly synchronize or control this access. For example, if two users initiating a transaction at the same time on the banking app, a race condition might allow both transactions to withdraw funds from the same account, exceeding the account balance. Attackers can exploit these scenarios by intentionally manipulating the timing of the events, leading to unauthorized action or resources access. Okay, so like if you look at the screen over here, you get check A for 1,000, check B for 1,500. Both both bank received two checks at about the same time, and both were drawn on an account that has only 2,000 in it. Without risk condition, okay, preventive measures, the account could easily be overdrawn, and then you will end up with account balance decrease to minus 500 here. So the mitigation methods are a lot. I would just describe a couple of them. You need to implement locks to ensure that only one process or thread can access a resource at a time, preventing conflicting operation. And there's another one that's called proper synchronization to ensure processes or threads work in a coordinated sequence when accessing shared data. Now, we have using hidden elements in the web pages here. Okay, so hidden elements, by the way, are not visible to users, but can easily be inspected or modified using browser developer tools. You know, potentially exposing sensitive data like user ID, session tokens, or application logic. Now, web developers often use hidden element in HTML, like you see it here, input type hidden, okay, to store data exchange between browsers and server. While this can simplify the communication, it poses security risk if the hidden elements contain sensitive information. Like, for example, an attacker might manipulate a hidden field containing the user role, okay, to escalate the privilege. This makes this makes the use of hidden field manipulation attack. That's what it means. So there's an actual attack called hidden field manipulation attack, which is, it's a type of web application attack that involves modifying the values in the hidden field in a form here. So if you look at the figure here, here we have the user ID value is stored in a hidden field. Here's the input hidden field, which can be manipulated by the attacker. Okay. Now, the secure way to implement this would be to store the user ID in a session variable on the server side and use that value to process the form data. Now, to mitigate this risk, developers should avoid placing sensitive information in the hidden elements and instead use a secure server-side mechanism to encrypt and validate all data sent via the client. Now, one of the tools you could utilize to modify the hidden one, that could be like using, Burp Suite, which is a very popular proxy tool used to intercept and modify, HTTPS traffic, including hidden fields. Basically, it allows manual testing and manipulation of hidden fields. Now, unprotected application program interface API. If you look at the screen over here, here we have different type of application, like in the mobile, on the browser, the access API, which is, as you see, an interface provided by the software application to allow other application, here's the other application right here, or developers to interact with the system programmatically, enhancing functionality and enabling integration. Okay, now, so basically, this application here will interact with the database through an API linked to the business logic here. Now, if API, if the API here is not properly secured, they can pose significant security risk. For example, API that lack encryption, like HTTPS, can expose sensitive data in transmit, making it vulnerable to interception by attackers. Similarly, APIs without authentication or access control can be abused by unauthorized users to exploit the system, such as extracting, like sensitive data, performing privilege action, or even like overwhelming the application with exclusive requests. They call it API abuse. Okay, so now we know the risk. What are the mitigation now? What encryption? Use HTTPS to secure data and transmit. You need to do authentication and authorization. Like you need to implement API keys, JWT tokens to verify restrict access. You need to do like rate limiting, prevent abuse by limiting the number of requests a client can make. Input validation, you keep hearing this over and over and over again in many, many, many things. Input validation will help reduce so many attacks, by the way. Monitoring and logging, track API usage for anomalies and authorized access attempts here. Now, last one here, we have unsigned code. Now, unsigned code refers to software or device drivers that lack a digital signature, let's say, by Microsoft, making verifying its authenticity or integrity impossible. Now, digital signatures helps and enabled, of course, it has to be enabled by digital certificate and public key infrastructure, PKI. These are very important to confirm that the code originates from a trusted source and has not been tampered with or manipulated. Like, for example, here, okay. Windows operating system requires device drivers to be signed by an approved code signing certificate authority or trusted entity to gain kernel level access. Okay. Now, this prevents malicious or unauthorized software from compromising critical system components. Okay. Now, the thing that you need to know, unsigned code, okay, poses a significant risk because attackers can distribute malware disguised as legitimate software without a signature. Now, the problem here, a user who accept to install something, okay, without verifying the signature code, for example, you know, I mean, basically, the users have no way to confirm its origin or integrity, you know. And if they say okay to install it, then they are introducing threat to their system. Okay, so what is the best practices for handling code signing? Enforce code signing requirement. System should require signing application, libraries or drivers before installation, especially for kernel or privileged access. Use trusted certificate authorities. This has to be done by developers. By the way, they need to obtain code signing certificate from a well-known CA, certificate authority, to ensure trustworthiness. Enable code signing verification, which means that the operating system and the environment should validate signature before executing the software. And of course, you have to always update the root certificate in the system. Now, finally, I want to thank you so much for watching this short video lecture. I hope you find this video useful. If yes, please hit the like button and subscribe to my channel. Again, thank you so much for watching.